In this video, we're going to take a look at law of sines. Now, before we do that, let's have a quick conversation. What methods do we have so far for solving for sides and angles of triangles? So if you want to pause it real quick and think about which different ways can we solve for sides and angles. So if we're thinking through sides and angles of triangles, we have a couple of different methods. If I have some sides looking for angles or vice versa. The first one that we should know, we've got the Pythagorean theorem, right? So this one says if I've got three sides, or if I have two sides of a right triangle, I can get our third side, right? We also have our triangle angle sum. If I've got two angles, I can get a third angle. Okay. Now that does not have to be for right triangles. That could be for any type of triangle, right? All right, let's see. What else do we have? So we just got out of special rights and sine, cosine, tangent. So we'll say right triangle trig. Okay. Now with right triangle trig, and I'm going to include special rights on this case. All right, largely the way that works is, again, assuming you have a right triangle. If you have two sides, you can get yourself one angle. Or if you have one side and an angle, you can get yourself another side. Okay, so that's largely the way that we have for solving for sides and angles. Now notice, and as special rights, if I know all the angles, or two of the angles plus one side, I can solve for the other sides, okay? But I could also use right triangle trig to do that too. So what we've found so far is it's pretty easy to solve for sides and angles as long as we have a right triangle. Now in this case, that's helpful, but it's maybe not super helpful because most of the triangles we have in life are not actually right triangles. So we need a different way to solve for right triangles. Now, hold on to that thought, or to solve for triangles that are not right triangles. Now, hold on to that thought while we move into talking about congruent triangles. So we're going to take solving triangles, and we're also going to take what we know about congruent triangles and kind of combine that and find a way to solve for sides and angles. Now, before we do that, let's talk about one definition here, and that is the definition for oblique triangles. An oblique triangle is just a non-right triangle. So those are the types of triangles we're going to be looking at. Now, what we're going to do will work for right triangles. It's much easier to do other things for right triangles, such as Pythagorean or SOHCAHTOA or something like that. But we'll deal with some oblique triangles and solve for some sides and angles. Now, one other thing, this is not SOL material, okay, and that could potentially help you on the SOL. This is more SAT type material. This is the sort of thing that you maybe won't have to memorize the formulas, you know, for the SAT, but you should be able to recognize them and use them correctly. Now, before we get into the formulas, let's take a look at how this relates with congruent triangles. So when we're talking about congruent triangles, we have a couple different ways that we know triangles are congruent. If I have SSS, SAS, ASA, AAS, or if I have HL. Now, HL implies it's a right triangle, correct? So we actually already have lots of ways for finding triangles, sides and angles with HL. So we're actually going to ignore that. Now let's look at this angle-side angle congruency. And I'm just going to make a triangle here, and I'll call this guy 50 degrees, and that guy is 60 degrees. I'll say that's a side of 10. Okay? What we know is that any triangle that has 50, 60, and the included side being 10 is congruent to this triangle right here. Or another way to think about that is that every triangle that exists that has 50, 60, and included side 10 has fixed values. This side must be a specific value. This side over here must also be a specific specific value. This guy over here must be 70 degrees. So we know that when we have angle, side, angle, it locks the triangle into place, that there are specific values. We just don't have a way to solve for them yet. Okay, same for side, 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 or side, angle, side. We know that any other triangle that shares those relationships shares all the other sides and angles. We just have been up to this point unable to solve for them. So what we're going to do is we're going to look at a way to solve for the sides and angles of triangles that have either angle, side, angle, or angle, angle, side given to us. And that way we're going to solve is something called the law of sines. Okay. Now we're going to look at SSS and SAS down the road, but you can't use law of sines to solve for side, 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 or side, angle, side triangles. Okay. But if you've got two angles and a side, thumbs up, we're going to be able to solve this, whether it's the included side or not the included side. So here's your law of sines. This would be a great thing to take notes on. Okay, this would be great to put into your notes. Now, the law of sines works like this. It actually works in forms of proportions, okay? Sine of an angle over the opposite side is equal to the sine of any other angle over its opposite side. Now, notice how A, capital A always implies, if it's capital A implies it's an angle, if it's a small letter implies a side, is opposite side A, and B is opposite side B, and C is opposite side C. Now, we don't always deal with sides with A, B, and C, right? It doesn't matter which one we call A, B, or C, just so long that the opposite angle or the opposite side shares the same letter, right? So we could call this, sine of F over side F if we wanted to, and so on, just so long that we have the matching letters here. All right, so we should have this in our notes. We're going to go ahead and use law of sines to solve for some missing sides and angles. So notice this triangle. Look what I have. I've got an angle. I've got an angle. I've got a side. So I've got angle, angle, side here. And I'm looking for another side. So here's what I'm going to do. Here's my A, capital A. Here, this would be my small a, right? This is C. This would be my small c. Now notice I don't have anything going on with angle B. Now I could solve for that angle if I wanted to, but we're not going to worry about that so much right now. Okay, so what I'm going to do is I'm going to set up my sides. Okay, and let me make that look a little more like an A and a little less like a 9. I don't know that that's actually any better. Well, you'll have to deal with it. All right, so let's go ahead and set this thing up. So I know, here's my formula. Sine of A over A. Now I'm generally only going to use two of these at a time. All right, so I'm going to do sine of A and sine of C. And it's called law of sines because, well, we use the sine function. Sine of A over A, sine of C over C. Now let's go ahead and plug these in. Sine 47 all over 14 is equal to sine 34 all over x. All right, now at this point we can cross multiply and solve for x. Remember, this 14, it's not going to multiply into 47 or divide into 47 or multiply by 34. Remember that when we're talking about these are functions of a particular value. So when I cross multiply here, I get x sine 47. Oh, not what I wanted to do. Here we go. Come on. I don't know what just happened there. I lost my pen. All right, there we go. Is equal to 14 sine 34. All right, and then I would divide both sides by sine 47. Okay, not 47, sine 47. All right, so x is equal to 14 over sine 34, or times sine 34 divided by sine 47. All right, so we're going to plug this into our calculators because unless you have the values for sine of 34 and sine of 47 memorized, that's what we're going to have to do here. And we end up with something like x is equal to 10.7. Okay, 704, we'll round to the nearest tenth. That's a general rule of thumb when we're dealing with sides. So we get 10.74, or 704, so 10.7. Now, look, if you got the answer of 59.9, One, you should start to realize this probably doesn't make a lot of sense. And two, you should probably check to see if your calculator's in radian mode. Remember, to solve anything with sines and cosines, we do need our calculators to be in degree mode. And so if you're in Desmos, you're going to have to hit the little wrench in the top right corner, go down and hit degrees. If you're on a TI-83, TI-84, you're going to hit mode. It's at the top middle. You're going to roll down until you see the word degree. You're going to hit enter over that, and then second mode gets you out of that menu. All right, so you should get 10.7. Now, one thing to check here, you can do this with SOHCAHTOA or law of sines, law of cosines. You can always check your answers using triangle inequalities, right? 34 is a smaller angle than 47. So the side opposite 47 should be bigger than the side opposite 34. Now, it's not a lockdown proof that this is the right answer, but you can at least check to see if your answers are making sense. So 10.7. Smaller than 14, but it's not tiny like 0.1 or 0.2 or something where it's clear that we made a mistake. All right, let's look at another example here. We'll just do this one last one, because we've kind of gone kind of slowly here. So let's move a little faster here. So notice I've got this pair here with angle D. Okay, so I'm going to do sine of, and I'll just use the letter D here. All right, and then look, I don't have another matching set. How do I know if I'm using E and F and F? Well, I need a matching side and angle, right? I've got this set right here. That's with my X, okay? Whichever one has the X, we're going to need that, right, to solve. However, I need another matching set of side and angle, opposite side and angle, in order to solve this. But this one is matching the side. This one is matching the angle. So what am I going to do here? Well, how about I solve for the missing angle? So what I'm going to do real quick is I'm going to do 180 minus 84 minus 41, all right? And that ends up being 55 degrees, unless I did it wrong in my head, but I don't think I did. That looks like 55 to me. All right, so 55 degrees. So now I have a matching side and angle, so I'm going to do sine E all over 12. Or in that case, sorry, if we're just writing out the formula, sine E all over E. So let's go ahead and plug this in. Sine 84 all over X is equal to sine 55 all over 12. All right, if I cross multiply, okay, I'll let you do that on your paper, but if I plug that in, sine 12 sine 84 divided by sine 55, I get something like 14.56, or I will round that to 14.6. Now again, let's use triangle inequalities. 55 is less than 84, so I should expect 12 to be less than whatever I solved for. I got 14.6. Thumbs up, that seems reasonable, okay? Law of sines is, at least up to this point, is not very difficult, okay? You plug it in. Now, some of the problems are going to ask you to solve for multiple sides or multiple angles. And, okay, so don't stress about it. Here's what you're going to do, okay? Oh, I lost the side of my triangle doing that. Let's not do that, okay? Trying to see if I can get this out of the way. There we go. Okay, let's say they also ask you to solve for y. Well, no worries. Here's what we're going to do. We're going to do the exact same thing we did before. Okay, sine 55 over 12, that remains the same, right? And if I'm looking for y, then I just set up a second proportion, sine 41 over y, and then I cross multiply and solve. Okay, so you can solve for multiple sides and angles. Okay, and on this one over here, you know, if you're looking for the opposite side and angle, then yeah, you'd subtract from 180 to get that angle. Use law of sines again. Okay, so that is our first video, our first lesson, our first assignment, all of that on law of sines.